Hey, good afternoon, everybody. Today we're going to talk about the MK Morse 14-inch Metal Devil dry cut saw. We wanted to talk about it for two reasons. One, it's a staple item here at Purity Cylinder Gases. We've had a lot of success with this over the years. And then there's a few things regarding blade technology that has just recently come out that we want to make you aware of as well. This technology, which we're going to refer to as a dry cut, and want to explain how that differs from the abrasive cutoff saws that so many are using today. When we think about an abrasive saw, the one thing that most people are familiar with is the tremendous amount of spark that you get with an abrasive saw. It's a high-speed cutting action using a blade similar to this, what we call a bonded abrasive. As you're cutting, the blade's wearing away. As you're pushing through and things heat up, this blade has a tendency to want to deflect as it goes through the material, which would reduce the accuracy of your cutting. So then we flip over to the dry cut saw. You can see we employ a carbide tooth, but this tooth has a composition of ceramic in it. So it's referred to instead of just as a tungsten carbide, it's a cement tooth. Ceramic dissipates heat and it helps aid in the metal cutting process to keep that blade cool. Heat is always the enemy. We're actually milling. We're taking a chip instead of grinding and getting real small particulate. So that chip is where we carry the heat. We'll see cooler cutting, so we don't temper the steel as much. The other thing is this blade is more rigid, so it won't deflect, therefore we get a more accurate cut. Let's take a look at the saw, the Morse saw, a little closer. We got this nice big D handle. And on this D handle, there's two switches. So it's a redundant switch system. If you look at the blade, a much heavier shrouding system. Now, there is this hand tray down below, which I've emptied out. The other thing you'll notice is this dual blade guard that retracts. So, blade is fully guarded until we come down and start into our cut. Then the teeth are exposed. You've got a miter capability up to 45 degrees. This saw, unlike some of them, doesn't have a rapid take up for closing the gap. You have to turn it, but it's got a nice heavy duty Acme thread that'll endure the life of the saw, no problem. One thing that Morse does, and I've not seen with any of the competitors, is they produce these are an accessory, but it's a V-block. Bolts right into your vice jaws. In changing the blade, you've got 3 screws that are Phillips screw. Now you just back those out. Blade guard just swings out of the way, but it doesn't ever come off. And that's a nice safety feature. There's 2 Allen wrenches total that you would use for this saw for any adjustment, and they're right here. Now it's also important that when you put that blade on there, that you make sure that the rotation is correct. In that blade, you can see right here, you want that tooth coming down counterclockwise into your material. Morse installs this little chip guard right here. In transporting the saw, they just have this real simple hook and loop system. Really at about a $500 price point, it's a great entry-level saw. It's a great saw for maybe as a auxiliary cutting area. Throw it back, we'll pick up. It's just very versatile. First and foremost is whenever you're changing the blade and doing your setups, make sure the saw is unplugged. Make sure it's on a stable base. It's ideal if you can bolt the saw down to a table or a workbench. I like to wear gloves, some type of protective clothing. You gotta remember, this chip can become airborne, and particularly what happens if that which isn't caught in the basin tends to deflect off to the right of the saw. So right where our cameraman is standing, he's in a perfect spot where he can get pummeled with some hot molten steel chips. Look around to make sure there's nothing that's going to be flammable. Safety glass is at a minimum. Like we mentioned with that shrapnel flying around, it's a really good idea to have a face shield. As far as cut capacity, we can cut round, we can cut square, you know, a lot of tubing, a lot of structural type things. Strut, you can cut mild steel, aluminum, stainless, all appropriate for this saw. If we're cutting square at 90, we can cut 4 3/4 by 4 3/4. So it's got a pretty good cut capacity. You can cut heavy wall with this. The saw will cut solids as well. If we were to just cut it like this, we're going to be cutting across the flats, then we're going to have this thin wall, then we're going to be cutting across the flats again. You know, an interrupted cut. Well, the rule of thumb is you want to have that tooth in the material the least amount of time possible in order to optimize your cut. So with these V-blocks, what it allows us to do is stand that material up. So we're consistently cutting through the thickness of the material instead of across the flats. It's a constant RPM, 1300 RPM. You see a lot of similar saws out on the market that will be 1500 RPM, 1450 RPM. My experience has been 1300 RPM is about optimum for this type of cutting. So we don't control the speed of the blade, that's constant, 1300 RPM. But what we can control is the rate at which we feed the material into, the blade into the material. We don't want to go too slow and we don't want to go too fast. Well, how do you measure that? One thing is, we mentioned that this saw won't produce a lot of sparks unless we go too slow. If you take too small of a chip, that heat that we create is going to look more like a spark because it's going to be that much hotter. There's not enough material to sink the heat into. If we take too big of a chip, it's going to be too much of a stress and load on the blade. More often than not, we find that the end users are not going fast enough in their cut. What we want to start with? I'm going to start with this little piece of angle iron. Should we do it like this? Should we do it like this? You really want to make a teepee out of it. This is going to be your optimized method for cutting angle. Got to find our piece. Fell off the table. So one thing that I want to point out with this cut that we just made is there's just no burr there. All right, let's cut a piece of flat stock. Actually, I'm gonna cut it 3 ways. I'm gonna cut it flat, I'm gonna cut it straight up, and then I'm gonna cut it at an angle. Again, pretty clean cut. Just a little bit of a real light hairline burr there. Much faster. Get about the same results on finish. Got a piece of this tube here. Just for fun, let's take a temperature of the material before we cut it and after we cut it. 67 degrees. Right away out of the cut. 72 degrees, 71 degrees. So we jumped 3 degrees in that fast of a cut. You can see there's a little bit of a bluing in that chip. That's because of the heat created through the cut. Now this happens to be MK Morse's newest blade. What they've done on the redesign is it's a thinner kerf. We're removing less material, so we're through material much faster. Behind us here, we've got the lineup of offering. This is the one that we have in the saw right now. This is for steel. stainless and thin steel, which is a 90 tooth. And then we make an aluminum blade, 80 tooth, and a thin aluminum blade, 100 tooth. Personally, I kind of like just leading in with the 66 tooth blade for metal or stainless or aluminum. And I think you end up getting about the same blade length. Now, we haven't tested the new generation, so we're going to be doing some of that and see if we, our end user customers tell us anything different. So the question is, are you running with the devil? And if not, should you consider it? We at Purity have demo units. We work closely with our Morse factory reps in the field. We can come on location to your facility and we can do some test cutting, take your materials, run them through the saw. Morse is first and foremost a blade company, but when it came to putting some saws out there, I think they did their homework. If your saw's not cutting it, you might want to take a look at this one.